grade 11s, welcome to another series of iCampSA lessons. Today we have a very interesting problem, which is exponents and sets problem, where we are being told to simplify the following expression, right? So the first thing that comes to my mind where I see such an expression is I need to break this down. I need to break this one down and this one. So I need to break those two down, right? I've not started with simplifying. I'm just applying my laws of exponents to break it down, right? And write it as a basis of 9 both, right? And basis of 3. So let's see. So I still maintain my 9 times 4 to the power of x minus, this can also be written as 9 to the power of x times 9 to the power of 1, right? It's the same thing. Then I can write 3 to the power of x plus 1 as 3 to the power of x times 3 to the power of 1 minus 3 times 2 to the power of x, right? Great. Then I open my equal sign. So I want you to notice something here, right? I want you to notice something. So what I'm trying to have numbers with the same basis so that I can be able to apply my laws of exponents, right? But what I have here is I have a common factor, right? I have 9 and 9 here as common factors. And then on my denominator, I have 3 and 3 as my common factors. So I'm going to try and take that as a common factor and see what I'll be left with, right? So I have this and that. I also have, let's use a different color. I also have 3 and 3, right, as common factors, right? So I'm going to take those out. So I'll have 9 into 4 to the power of x minus 9 to the power of x, right? And then I have 3 to the power of x minus 2 to the power of x, right? Great. So what I have now is I can see that I can simplify that and that, right? Because it's going to be the same thing as 9 divided by 3, right? So how many times does 3 go into 9? It goes 3 times, right? So here it's going to be 1, here it's going to be 3, right? So let's continue. So now I'm going to be left with 3 into 4 to the power of x minus 9 to the power of x all over 3 to the power of x minus 2 to the power of x, right? Now, what comes into my mind, right, is it's not clear as to how I can proceed further, right? So what I'm going to try and do now is I'm going to try and simplify these, right? I'm going to try and simplify that. So I can write 4 as 2 to the power of 2. I can also write 9 as 3 to the power of 2, right? So that's what I'm going to try and do now. So it's going to be 3 into 2 to the power of 2x minus 3 to the power of 2x as well. Close bracket minus, close bracket all over 3 to the power of x minus 2 to the power of x, right? So here's an interesting thing here, right? Here's an interesting thing. When I look at this, this and that, right? They almost look similar, right? They almost look similar, but the difference is the signs, right? The difference is the sign. So here you have a 3, you have a 3 raised to the power of 2x, right? Here you also have a 3 raised to the power of x, but the 3 raised to the power of the 3 raised to the power of 2x is negative. Here it's positive. The same here, it's positive. Here it's negative, right? So I want to arrange these in such a way that they will almost be similar, right? So the best way I can do that is I'm going to try and look at this, right? So this, right? So this can also be written as, if I take out a negative sign, right? If I take out a negative sign, let's say, and it's going to be a negative sign, or let's just say -1, right? Into, right? What is negative here? 2 to the power of x is negative. So I'm going to try and put it here. So it's going to be 2 raised to the power of x, right? So if I say -1 times 2 to the power of x, it's going to give me what? It's going to give me -2x, -2 to the power of x, right? So I've taken a negative sign, which is -1, and if I say -1 times 2 to the power of x, it's going to give me the same thing as this, right? Now what I want is, I want a 3 to the power of x, right? And I want it to be still positive, right? So in order for it to be positive, I need to find a sign that when I multiply it by negative, it's going to give me a positive, right? So it's going to be negative, right? So this is going to be -3 to the power of x, right? So essentially it's the same thing, but what I've done is I've changed the positions, right? I've changed the position of 2x and the position of 3x, right? Because if I say -1 times -3 to the power of x, it's going to give me positive, which is this one, right? So what I've essentially done is I've changed the negative, I've applied the negative sign and changed the positions. So now what I'll be left with is going to be negative, okay, it's going to be 2 to the power of 2x minus 3 to the power of 2x all over, you have a -1 into, you have a -1 into 2 to the power of 2 to the power of x minus 3 to the power of x. Right, so what I have here is, if I look at both these, right, if I look at both that and that, now it almost looks similar, but the difference is the exponents, right? The difference is the exponents, right? So now I want you to take note of this, right? I want you to notice this. So this expression, right? This expression, right, which is, let's just write it here, which is 2 to the power of 2x minus 3 to the power of 2x, right? So this expression is going to be a difference of 2 squares, right? It's almost a similar thing as, let's say, if you had x squared minus y squared. This is the same thing as having x minus y, x plus y. right? Because this is going to give you x squared minus xy. No, it's going to be x squared plus xy minus xy minus y squared, right? So that and that will cancel, and then you will be left with x squared minus y squared, right? That is when we do that, right? Right, so what I'm going to try and do is I want to write this, right? I want to write this as that, right? Because if I do that, it's going to give me a similar bracket as this one, which I'll be able to cancel out, right? So now I can also write 2 to the power of 2x minus 3 to the power of 2x, which is the same thing as 2 to the power of x minus 3 to the power of x into 2 to the power of x plus 3 to the power of x, right? So this is still going to give me the same thing, right? When I multiply the brackets out, it's still going to give me the same thing, right? So I'm going to take this and substitute it there, right? So now I have 3, which is going to be 2 to the power of x minus 3 to the power of x into 2 to the power of x plus 3 to the power of x all over negative 1 into 2 to the power of x minus 3 to the power of x, right? So now what I have is similar things, right? I have similar brackets. So this and that are the same, right? Which means they can literally cancel each other out, right? So this and that are the same, so we can cancel them each other out, right? So negative 1 divided by positive 3, it's going to be negative 3, right? So what I'm going to be left with is negative 3 into 2 to the power of x plus 3 to the power of x, right? So when I'm here, I don't need to simplify it further. When I say this, I can see that this has already been simplified, right? But if you like, you can simplify it further by saying negative 3 times 2 to the power of x minus 3 times 3 to the power of x, right? And if you like, you can also write it as 3 times 2 to the power of x minus 3x plus 1, right? So you've actually simplified it in this manner, but ideally you can literally stop here, right? You can stop here. Here is, if you like, right, if you like to simplify it further, right? So you can literally stop here. So this was a very interesting question. It was just testing your understanding of exponents more than anything, right? It's testing your understanding of exponents and also your application of difference of two squares. It's an application question more than anything, right? These are types of questions that you find in your prelim or in your final exam, right? Because now you have done everything So what they want to know, or what they want to find out from you, is whether or not you can apply the principles of mathematics in questions, right? Yeah, so this brings us to the end of this question. Let's go and look at another question. Thank you.